Hello, my name is Daniel Soto, and I'm with Challenge 2016, and this is the third interactive video for Calc 2000. In this video, we are called to find the area of an ellipse, and an ellipse is equal to this formula over here of x squared over a squared plus y squared over b squared is equal to 1. And this is how an ellipse looks like. Okay, now to solve this formula, we're going to need to first convert it into the y form. So we'll get y squared over b squared is equal to 1 minus x squared over a squared. And so now we'll move over to b so that it's y squared equals b squared 1 minus x squared over a squared. And we're going to convert that also into x over a squared after we take the root. So now we'll have y equals the root of b squared, which is just b, so b root 1 minus x over a squared. Okay, now that's a formula that we're going to work with, and this is actually equal to plus or minus, because you'll find that this will be equal to, we'll just change up the color so that we can get a better visualization. Okay, so this is the positive area, and this would be the negative area. So blue is negative. And so what we're going to want to find, that would be equal to the entire area, but we'll find, in most cases, well, with a circle you would do 1/2 a because it's simple, and it's simple to do since the radius doesn't change. But since this is with a different y interval, then it would be equal to a. So since a is not equal to b, a is not equal to b, we will do 1/4 of the area. And so let me just color code that. We'll find 1/4 of the area right there in green, and that will be equal to integral from 0 to a of y dx. And then we'll plug in for y. Only the positive part of y. And let's do that on the next page. Okay, so integral. So let's see, 1/4 the area is equal to integral 0 to a of b root 1 minus x over a squared dx. And since b is just a constant, we'll shift that over to the outside. And so it should actually be b times that integral. Okay, now we're going to have to swap in for the root and for the dx. So let's do that. Let's write a triangle. So this is theta, and now using Pythagorean theorem of a squared plus b squared equals c squared, we'll find out which values are appropriate to which area. So and this a, b, and c are just arbitrary. So to avoid confusion, let's change it to d, e, f. And so now we have e squared is equal to f squared minus d squared. And if we take the root of that, we'll get a similar, we'll find that this is very similar to what we have in our integral, which is 1 minus x over a squared, since a can be squared, since 1 can be squared. So using logic, we can assume that f, the hypotenuse, is equal to 1, and then we can swap in this root for either side of the triangle. For simplicity's sake, let's swap it in for the adjacent side. So 1 minus x over a squared, and this will be, in the opposite side, would be equal to x over a. Okay, now we're going to sub those in, and this is similar to U substitution, but it's with trigonometric values. And so we call it a trig substitution. Now I'm going to have to erase this Pythagorean theorem and then start finding some values for the x. So let's start with the root. The root is equal to cosine, let's go with cosine theta, is equal to SOHCAHTOA, where cosine is equal to adjacent over hypotenuse. And so this would be root 1 minus x over a squared over 1. So we'll just say that cosine theta is equal to our value of root 1 minus x over a squared. And then we'll find a value for the dx, so we'll have to take the derivative of something. So to make it easier, we'll do sine theta is equal to x over a over 1. And so, but since it's over 1, we can just discount it. So it's just x over a. And so now we'll take the derivative of that. So we'll have cosine theta is equal to, I skipped a step. We actually have to move this a over to the other side. So it's a sine theta is equal to x. And so now we'll take the derivative of that. And so we'll have a cosine theta is equal to, a cosine theta d theta is equal to dx. Okay, now these are the values that we're going to be substituting in. A cosine theta d theta dx, and then cosine theta is equal to 1 minus x over a squared, root 1 minus x over a squared. And so we'll do that on the next slide. So 1/4 of the area is equal to b integral 0 to a. And so now we'll swap in the values right now. So cosine theta times the value that we have substituted for dx, which is a cosine theta d theta, and a is just a constant, so we'll move it over here so that it's to a b integral 0 to a of cosine squared theta d theta. Now we'll convert that over. So b a is equal to 0 to a of 1 plus cosine 2 theta over 2 d theta, because that is a trigonometric value that is equivalent to cosine theta. Okay, cosine 2 theta is trigonometric identity where it is equal to 2 cosine squared minus 1. 2 cosine squared theta minus 1. And so if you move all the values over, you'll get that cosine squared theta is equal to 1 plus cosine 2 theta over 2. And this 1/2 is also a constant, so we'll move it to the other side. So we'll have a over b over 2 of 0 to a of 1 plus cosine 2 theta. And now we'll evaluate this. So we'll get ab over 2 of theta plus 1/2 of sine 2 theta from 0 to a. And we're going to have to bring back some of the values that we had from before, which are that sine theta is equal to x over a. We'll now shift that to be that theta is equal to arc sine of x over a, and cosine theta, we'll use that in a second, is equal to root 1 minus x over a squared. Because sine 2 theta is actually a trigonometric identity, which is equal to 2 sine theta cosine theta. And we're going to have to do that on the next slide again. So 1/4 of the area is equal to a over b over 2 of theta plus 1/2 sine 2 theta. And from 0 to a, from a to 0, 0 to a. Now we'll plug in some values, and we're also going to change it to being the whole area, so it's 2ab of arc sine x over a plus 1/2, and now we're going to be doing some value substitution right here, so sine theta, cosine theta. And so it's times 2 times sine theta is equal to x over a. So x over a times root 1 minus x over a squared. A to 0. No, well, 0 to a. And now we'll plug in those values to a b. And so we'll have arc sine of a over a, which is equal to 1. So sine of negative 1. Sine of 1, arc sine of 1, and arc sine of 1 is equal to pi over 2. Plus the 1/2 and 2 cancel out. We'll have a over a times 1 minus a over a squared, so we'll have 1 times root 1 minus 1, and so that will be just root of 0, which is equal to 0, and so we'll have a 0 for the second value, and then we'll have arc sine of 0 over a, which is equal to 0, and then we'll have x over a, we'll have 0 over a times 1 minus 0 over a, so we'll have 0 times root of 1, which is again equal to 0. So our final value will be that area is equal to 2ab times pi over 2, and so the 2's will cancel out, and so we'll have the area of an ellipse is equal to pi ab. So that is the answer to what the area of an ellipse is, and is done through integration. Thank you for watching, and see you soon.